So here's the CNC controller, brand new, and I'm going to connect it to my 4 drivers for my X, Y, and Z and A axis on my milling machine. Here's the board. The Pokeys unit has been mounted. The older driver has been removed, and I've set up a couple buses for plus 12 volt and ground. And these connectors are the 8 motor output connectors available on the Pokeys unit. I'll use 4 of them to connect to the 4 drivers. You can see that the connections are a lot different. This is an Ethernet type connection, and the motion board has a ribbon connector. So Pokeys 57CNC connection diagram for all of the various connectors on there, and right here we have the 10-pin motor connectors, and right here we have the designation. All of the back row are ground, and here we have the designation of how the connections should be made. So using that, I made myself a little chart. This represents the Ethernet type connector, whatever they call it, and so then I identified what each of those were doing using a pinout of the main connectors for the drivers. And so what I have to do is put all those in the correct place on the 10-pin connector, and match them all up and snug them all in there. I hope you can see those little pins there that the wires have to go into. And here I'll put my finger in the picture to show you how small all of this is. So I tried doing it in various ways with a screwdriver and so forth, couldn't do it. The piece that normally is used to push the wires down into the connectors is this little thing, and you can see that it mashes the wires down into these tiny little grooves that they're supposed to go into. And I tried doing that, lining up the wires and then pushing this down on there. Goes down like that on top. And what happens is that this little end locks onto that little tab that I hope you can see. And so if you get the wires in there wrong, it's pretty nearly impossible to get this thing back off. So what I did was take one of these and sacrifice it, made a tool out of it, and all I did was cut the ends off the legs so that it could no longer lock in there. So what happens is I put a wire where it's supposed to go. I take this and I push it down on top, lock that wire in, take it back off, do the next wire, and do all 5 wires like that. Then after I look at it very closely, after it looks like it's all correct, then I take the one that still has the locking tabs on it, and I mash that down in there, and the job is done. Takes a little bit of a while, and I'm going to try to set the camera up so you can see me doing one of them. We'll see how it comes out. So this is the kind of thing we need to make with a connector to the driver there and a connector to the motion device with one of these little things. And then we need to take the ground wire, which runs all the way from here to here, and we have to tap it and run that to 12-volt ground, and then a wire that only goes into here and to the driver with 12 volts. Now the reason for that is that the Pokeys57CNC is not able to handle enough amperage to drive the CNC drives, the drives that I'm using for my particular servo motors. So this is the animal we have to make. Now there are some problems, at least for me, in doing that, because this little connector here is very, very small. It is designed to connect to a ribbon cable where all of the wires are in sequence, and you just slip it in there and slip a top on, and that locks and pushes all of the wires into their correct connection confirmation. But these are individual wires. 5 of them have to go into the correct places, so I had to kind of invent a way to do that. So here is one of the cables that I was using before with the Ethernet smooth stepper. This part is wired into the driver, and this part went to the terminals on the C25 board, which was plugged into the smooth stepper. So it was kind of messy, and once you get this arrangement with these connectors on the end, it makes for a much neater job. Now there are also boards made, breakout boards, which would make this job easier, although I don't think any neater. You can get some board that would connect the driver with the Pokeys board, but there's really no need with the Pokeys board to have a breakout board as far as I can see. At least for all the uses that I'm going to make of it, we can just use this direct connection method. So what I'll probably do is start by snipping these all off fairly even and getting rid of those, and then I'm going to try to very gently slit this thing. Okay, so I got that slit and pulled out the wires, and the wires that I'm interested in, according to my chart, are the brown and the brown striped. So all of these can go back inside there, and they go in there pretty easy. So we'll untwist these. So the brown will be a ground, and the striped one will be plus 12 volts. Okay, so I've tapped these two wires. The 12 volt wire I simply cut and spliced another wire onto it, and the ground wire I've tapped into the middle of that. So now I'm going to put a little shrink wrap on there, and I did not solder the joints. I suppose I should, but I've done this lots of times, never really had a failure. So and now I'm going to take a piece of another piece of shrink wrap, and let's see. So they're all in there now. Okay, so we have the hot wire, the ground wire for 12 volts tapped in, and now the next job will be to connect the important 5 wires into the tiny little connector, and I'm going to reset the camera for a close-up here on my little vise, and we'll see if you can see me struggle to get these little wires in place. Okay, so the first wire is that I want to put in there is the blue striped wire. And I get that in there, and then get this pusher tool, push it down, pull it off, and I hope you can.
The orange goes into the number.
Well, it's damn cold here in Florida. It's down, well, this morning it was down in the 40s, and here in Sarasota we consider 52 to be freezing. So anyway, well, after what you've just seen, I took all 4 of these cables that I had made up and plugged them into the board, connected everything, fired up Mach 4. Doesn't work at all. I went through every setting that I could find, and one of the things I started to realize while I was doing this is that there really aren't a whole lot of settings to get this thing working. Anyway, since my lathe was working or is working, I went and checked those settings, compared them to what I was doing on the mill, and everything looked right, but the damn cables, something was wrong, didn't work. So I took them all apart and I tested them one by one by connecting various axes, and still nothing. So then I started to continuity check each of them, make sure I hadn't crossed pins. I looked at where I had them connected. Everything looked right. So finally I went over to the lathe board and took one of those cables and used it on the mill. Voila, it works. So evidently I had made up 4 cables and I made them all wrong. Wonderful. So I start looking at this, and if you remember when I was talking about this, and in the video I was saying there were only 5 wires to connect. Well, wrong. 6. The one on my, I'll have a paper here now, but the one on the paper that was marked ground, there were 2 marked ground, and I figured it was enough to connect to one of them. I thought, well, they get connected in the driver anyway, but that's not correct. So I was missing one connection, and I repaired all of that. Actually, 2 of the cables I totally remade, and then 2 of them I kind of cheated. I opened up the cable in the middle and shorted out the 2 grounds against each other, and from there on it worked. So anyway, it's working now. I'll show you a picture of the connections and how it all looks. So there it is, all connected. All 4 driver wires connected to the Pokeys board. On the right, you can see the wires going to the plus and minus 12 volt buses that I made. Follow the wires up and see that the other ends go into the Ethernet connectors on the servo drivers. And that's it.